This video is about the recursion and financial modeling chapter of our VCE examination year year 2016 further mathematics examination 2. Okay, so the recursion and financial modeling section starting from page 10, question 5. And now let's start. So again, um, now if you have done the 2018-2017 one, you may realize that there's a pattern over here, or we always start with um, this type of question first. And so if we look at question 5, we will see that my I have two equations over here. I have my V node and I have my V n plus 1. So my V node is equal to 15,000 and then my V n plus 1 is equal to 1.04 times Vn. So from I'm just going to label these as my equation 1 and equation 2. So for my equation 2, I can identify that it's a geometric sequence, right? Because there's a ratio between my n plus 1 term and my n term. So that's equals to 1.04, and that's the ratio in geometric sequence. So now let's look at part A. How much money did Ken initially deposit into the saving account? So initial, one way of we saying initial is node or 0. So V0 is the amount of money that's he can deposit into the saving account. So I don't even need to read the whole question. I can solve my part A. Now use recursion to write down the calculation that shows that the amount of money in Kane's account after 2 years V2 will be 16,224. So I need to prove that my V2 is equal to 16,224. So now it says write down equation to show that. So I need to write down recursion equation. And it's already given to us over here. So I know that my V node is equals to 15,000 and my V1 is equals to 1.04 times 15,000. And from calculation, that's equals to 15,600. So 15,600, yeah. And from my V2 equation, so remember that Vn plus 1 is equal to 1.04 times Vn. So if my notation over here is 2, which it means that my n plus 1 equals to 2. So my n is equal to 1. Now if I substitute v equals to 1 into this equation, my equation 2 over here, then I'll have V2 is equal to 1.04 times V1, right? So because my n equals 1, so I need to put V1 over here. Now I know that my V1 is equal to 15,600, so the equation becomes 1.04 times 15,600. And the final answer is 16,224. So that's how you write down the equation. So you have three equations over here. For the first one you need to have is the V node equals to 15,000. Second one you find out V1, and the third one find out V2 over here. And that's how you get the 1 mark. Now part C, what is the annual percentage compound interest rate for the saving account? So compound interest rate. Now we know that our geometric equation is Tn equals to a times r to the power of n minus 1. And then our compounded interest equation is a equals to p times 1 plus r over 100 to the power of n. Now I explained the relationship between these two. So I know that my 1.04 in my V2 is 1.04 means the R in my geometric sequence equation over here. So what's the R in my compound interest equation? Then my 1 plus my R over 100, which is the annual interest in percentage, is equals to 1.04 over here. So to solve it out, I'll find that my interest my interest rate as in percentage is equal to 4% per annum. The amount of money in the account after earned years weekend can also be determined using a rule. So you complete the rule below by writing the appropriate number in the boxes provided. So if you look at our equation over here, and this is the equation that they want us to find out. So first we have they have expressed the relationship for us through the recurrence relationships equation over here. So now what they want us to represent is represent that as our compound interest equation. So this one over here. Now instead of A, they put VN, so that's still the amount of money after n years. And my P over here is my principal, so it's my starting value, which is 15,000 in this case, we note. And I'm going to times my 1 plus 4%, or I can have it as 1.04. That's the ratio of my later term to my previous term, and it to the power of n. So n in the t equation over here, in the recurrence relationship, in the recurrence sequence over here, the n stands for the number of terms. And the n in the second equation, that for my compound interest equation, n stands for how many years after investment. Okay, so here my n stands for how many years after investment, and it's the same as what's described in the equation in the question over here. So I know that the base of this term is going to be 1 plus 4%, which is 1.04, and then times the initial value, or the principal, so that's 15,000. Yeah, 15,000. Okay. Now, so how much money will be in Ken's saving account after 10 years? So if we want to find out that, then we need to find out what is V10 equals to. Okay, because when VN stands for the amount of money in the account after n years. So if you want to find out the amount of money in the account after 10 years, that means my n need to be equal to 10. So my V10 over here will be equals to 1.04 to the power of 10 times 15,000. And it's equals to 206.66. Yeah, so $22,206.60. 66 cents. That should be a 3 over here. $203. Okay. Now question 6. First, caravan had a purchase price of this amount. After 8 years, the value of the caravan was this amount. Show that the average depreciation in value of the caravan per year is this much. So we need to find out how much the caravan has been depreciated in total. So that's 38,000 minus 16,000. So that's how much it has depreciated in total. And the depreciate happens in 8 years, because after 8 years, so the depreciate happens in 8 years, we need to divide that by 8. So once you carry that out, you will find out that's equals to 2,750 over here. So you need to write down the equation over here. When we ask you to prove something, you will always include the equation. So don't just write the answer there. Part B, let CM be the value of caravan n years after it was purchased. Assume the value of caravan has been depreciated using the flat rate method of depreciation. Write down a recurrence relation in terms of Cn plus 1 and Cn that models the value of the caravan. So now noted over here that it says flat rate and it's in bold over here. So that's called telling is simple interest. So the amount, we can use our simple interest equation over here, or what is saying that the amount of depreciation is same every year. Okay, so you always depreciate at the same amount. So and we already find out that it depreciates at the speed of $2,750 per year. So if we represent that is Cn plus 1 is equals to Cn minus 2,750. Part C, the caravan has traveled an average of 5,000 kilometers in each of the 8 years since it was purchased. Assume the value of the caravan has been depreciated using the unit cost method of depreciation. By how much is the value of the caravan reduced per kilometer traveled? So now it's saying that it's not depreciating on a yearly basis, but it's depreciating at a unit cost, so it's at a kilometer traveled based. But the amount of kilometer it traveled in each year is the same in each of the 8 years is the same. So because we assume that it's in an average of 50,000 years, so we will assume that so in that 8 years it has traveled 5,000 kilometers times 8 years, so that's 400,000 kilometers in total. That's the total kilometers being traveled. So how about the total amount of depreciation? So the total amount of depreciation happened was total depreciate is 38,000 minus 16,000, which is 22,000. So we want to find out the value of caravan reduced, so the depreciation per kilometers. So if we have the per kilometers over here, so we're finding out dollars per kilometers. So per kilometer. So if we find out that, notice that the slash over here, we can treat it as the vinculum. So like the vinculum of the fraction sign. So we will put my 22,000. So that's the total amount of depreciation, and then we want to find out how much depreciation is 1 kilometers. That's the amount of depreciation for 400,000 kilometers. So what we need to do is we need to divide our 22,000 into 400,000 part and find out what is each one part equivalent to. So so my answer over here will be 0.57 dollars per kilometer. Now let you know that even though I find out the relationship between Cn plus 1 and Cn over here, but that's not the recurrence relation. Okay, so I didn't state the beginning value of that. So I still need to say what my C node is equal to. So according to that, my C node is equal to 38,000. So I need to write all that. So for question 7, we're going to use the financial solver of your calculator over here, and that's so let's look at question part A. So for the so Ken has borrowed 70,000 to buy a new caravan, and he's been charged at the interest rate at 6.9% per annum and compounded monthly. So for the first 12 years, Ken was make monthly payments of $800. Now find out the amount that Ken was owed on his loan after he's made 12 repayments. So the number of payments been made is equal to 12. So in your financial solver mode, your n is equal to 12, and your I, which is interest, is equal to 6.9. N is equal to 12 because the interest is compounded monthly, and he's making the payments monthly as well. So there are 12 payments been made in a year. Okay, so and my present value is going to be 70,000. And the amount, the PMT that Ken's been paying is 800. It has to be negative opposite sign between my present value and my PMT over here. And the sign of them depends on which account you are taking reference as. So if you're taking reference as, let's say, Ben's borrowing money from the bank, and we are taking Ken's account as a reference, so the present value means he's been receiving this $70,000 at the start from the bank. So there has been $70,000 adding into account. And the PMT is the amount that he's paying back to the bank. So there's $800 being taken away at each payment over here. Now PV and CV are both equals to 12. Then you need to find out your PY and CY. PY equals to CY and they both equal to 12. So you need to find out your future value from the calculator. And in your calculator, you'll have it as this amount. Okay, so just press enter at your future value. So that's how much that he's owning after 12 repayments. So next, what is the total interest that Ken will have paid after 12 repayments? So from the first part, we find out how much that he's still owning. So we can find out how much he has paid off. So if we do that, it's 70,000 minus 65,076.22. So this is how much that Ken has paid out from the principal. But how much he has paid in total is $800 and for 12 payments over here. So that's how much that he that's the total of repayments. And here is the reduction in principal. So if not all the money go to pay the principal, then the difference between them is the part made to pay for the interest. So if you do the calculation, you'll find out it's equal to 4,676.22. Now part B. After 3 years, Ken was make a lump sum payment of L amount in order to reduce the balance of his loan. This lump sum payment will ensure that Ken's loan is fully repaid for a further 3 years. Ken's repayment amount remains at 800 per month and the interest rate remains at 6.9 per annum compounded monthly. So what is the value of Ken's lump sum payment? So there are two parts of this question. Now the first part is, so instead of in the previous one, we said we calculate his balance after the first 12 months. So now we need to find out how much he's still owning after 3 years, so after 36 months. Then my n will be equals to 36, my I is still equals to 6.9, my PV is 70,000, my CY and PY are all equals to 12. So find out my FV. So Sorry, I'm missing my PMT over here. So the monthly payment is still $800. Then my PMT is equal to minus 800. The sign need to be different over here. So this is how much that he's still owning after 3 years payments. So I know that at the end of the 3 years, or at the start of the fourth year, he's making another payment, and his target is, so after a further 3 years, that he's like the amount of loan will be paid off. So this is my stage 1, my first 3 years. So first 3 years. So the stage 2 will be my further 3 years. Further 3 years. So if my if Ken's loan has been paid off, then I know the future value that after the further 3 years will be 0 over here. And the amount of payment is still made over 3 years, so that's 36 payments been made. The interest is still 6.9. CY PY is still equals to 12 over here, and PMT is still negative 800. So what I need to do is I need to find out what is the present value. Okay, so what is the present money I need to pay for that, so that I know the future value of that will be 0. So from the calculation that I find out, if he wants after another 3 years, the future value, so the money owed to the bank is equal to 0, then he can only borrow this amount from the bank. So that's the amount of loan have to be left to be paid off. So what I need to do is, if you notice over here, there's a difference between the amount he owned after the first 3 years and the amount he owned in the beginning of the first 3 years. Okay, so the lump sum payment L is the difference between them. So L is equal to 4151.599 minus 25947.574. And the question asks us to round it to the nearest dollars. Then the lump money is $28,204.